Hi, I'm Taranjit Singh and today I'm going to talk about machine learning and its implementation in industry through internal and external strategy. Contents of this presentation include introduction about machine learning, then applications of machine learning, types and models, then deep learning and TensorFlow, then implementation of machine learning through internal and external strategy, and after that conclusion and references. So machine learning. During 1950s, Alan Turing developed a Turing test in order to prove a machine's learning ability. And then after that, in 1959, Arthur Lee Samuel coined the term machine learning. His Samuel's checkers playing program was world's first self-learning program. And machine learning is a branch of artificial intelligence in which computers are programmed to optimize their performance based on past experience or sample data. Some applications for machine learning include in manufacturing sector, machine learning can be used for predictive maintenance or condition monitoring, warranty reserve estimation, demand forecasting, and process optimization. In retail sector, it can be used for market segmentation and targeting, upsell and cross-channel marketing, recommendation engines. In healthcare, it can be used in alerts and diagnostic from real-time patient data, proactive health management, healthcare provider sentiment analysis. In travel and hospitality, aircraft scheduling, dynamic pricing, and customer complaint resolutions. In financial services, risk analysis and regulation, customer segmentation, cross-selling and upselling. And in energy and feedstock, it can be used for predicting seismic data processing, carbon emission and trading, smart grid management, and energy demands and supply optimization. Machine learning can be of two types, supervised and unsupervised. Supervised means an algorithm is programmed to conclude a function from a labeled set of training data. On the other hand, unsupervised learning has unlabeled set of training data. Examples of for supervised learning include prediction, classification, and regression. Whereas in unsupervised learning, examples are clustering, probability distribution, and estimation, finding association, and dimension reduction. Machine learning models. Machine learning models for binary classification problems predict a binary outcome, that means one of two possible classes. For example, in sorting whether an email is spam or not, will the customer buy this product or not, is this product a book or a farm animal, and so on. All these examples have two possible outcomes. Multi-class classification models. These models predict more than two outcomes. For example, is this book a movie or clothing? Is this movie a comedy movie, documentary, or thriller? Which category of product is more interesting to this customer? And so on. In the regression model, these models predict numeric values. For example, what will be the temperature in Seattle tomorrow? So it's a numeric value, and for this product, how many units will sell? Again, it's a numerical value. Deep learning. Deep learning is a subset of machine learning. Deep learning has multiple processing layers which are composed of multiple linear or non-linear transformation. When input layer receives an input, it processes it and then pass it to next layer in a modified form. Examples for sorry application for machine deep learning are automatic image caption generation, All major commercial speech recognition systems like Cortana, Amazon's Alexa, Google Now, Apple's Siri are all based on deep learning methods. Recommendation systems, drug discovery and toxicology, then object classification in photographs. TensorFlow. TensorFlow is a foundation library that can be used to create deep learning models directly or by wrapper libraries that simplify the process. TensorFlow is a multi-platform system that can run on laptop, PC, data centers, or mobile phones. The API for TensorFlow is now nominally for the Python programming language, although there is access to underlying C++ API. Implementation of machine learning through internal and external strategy. A firm may pursue new technology in two principal ways: internally, that means through research and development, or externally by purchasing the technology. Each activity has its own benefits and drawbacks, and each takes different types of skills. For internal strategy, we need to do planning. Before deciding on introduction of machine learning into small businesses, consulting employees and identifying problem will ease the transition. To innovate successfully, company need a disciplined innovation planning process supported by structured methods, tools, framework that can integrate multidisciplinary teams and multiple specialty areas such as market research, engineering, design, business management, branding, finance, and strategy. Then pre-implementation and implementation. Pre-implementation is a preliminary action like running a limited trial in order to test machine learning. Selecting and implementing one piece of technology at a time is always a smart move. This includes ensuring that infrastructure allows for easy data exchange and communication between surveyors, site supervisors, and machine operators. Providing frontline employees training with necessary skills and setting appropriate incentives to encourage their participation. Internal strategy, evaluation, and control. Evaluation of a firm's action is built around three key questions that are: where are we now in comparison with where we want to be? What lies ahead that can affect us positively or negatively? Where will we end up if we continue on this path? Answering these questions produce what is referred to as a gap analysis. The organization is looking for any potential gap between what it wants to occur or what actually has occurred and what is likely to occur. A gap analysis is particularly important for internal innovation. After the organization has evaluated its performance along these three dimensions cited, the firm's next answers the questions. External strategy. Merger or acquisition. Merger means to combine and acquisition means to acquire. These are two most commonly applied corporate restructuring strategies which we can use to implement machine learning. These are the form of external expansion whereby through corporate combination business entities purchases a running business or grow overnight. Merger alludes to the combination of two or more firms to form a new company either by the way of amalgamation or absorption. On the other hand, acquisition, also known as takeover, is a business strategy in which one company takes the control of another company. Nowadays, only few number of mergers can be seen. Therefore, we will go with the acquisition of new technology. Acquisition evaluation and acquisition options. Assessing whether a potential acquisition is a good match Technology acquisition involves assessing the match between technological capabilities and market opportunities, as well as the capability of technologies that other firms are developing. If the evaluation of a potential acquisition has yielded a positive result, the next step is to consider the detailed terms of acquisition. Then conclusion. Artificial intelligence, machine learning, and deep learning have become integral part of many business. AI is the broadest way to think about advanced computer intelligence. The core principle of machine learning is that machines take data and learn from themselves. This is the hottest technology and is currently most promising tool in the AI kit for businesses. However, deep learning can be expensive and require massive data sets to train itself on. These are the references you can look into it. The Management of Technology and Innovation, a strategic approach by Margaret A. White and Gary B. Burton. TensorFlow, a system for large machine learning, and Amazon Machine Learning. Thank you.